Hello, and thank you for joining us today. My name is Paul Thompson, and I am the North American sales leader for Remote Visual Inspection, or as we call it, RVI, here at GE Inspection Technologies. Along with me is my colleague, Tom Ward. Tom is our Senior RVI Product Manager here at Inspection Technologies. And co-hosting the event with us today is Stephen Berg. Stephen is the CEO of Berg Engineering, and who with his father, Jerry, for years, they have been selling and servicing non-destructive testing or NDT technology, including RVI equipment since 1969. Berg Engineering provides sales and full service of the NDT and material testing to all those industries that use that technology. At Berg Engineering, they're factory trained and they're certified by GE Inspection Technologies and have maintained customer relationships for over 50 years. And they offer a full suite of NDT products and services to help best serve the clients in their part of the world. Berg services include on-site training, either at the customer site or also they have a very nice classroom at their facility. They provide calibrations of equipment. They provide online or telephone or at your site free support where needed. They do preventative maintenance on equipment, and they're going to be here with us throughout this call. And I want to let you know that at the end of the presentation, the Berg Engineering team will also be hosting a live 30-minute Q&A session directly following this presentation. So meanwhile, please feel free to give us any questions that you have on the instant chat window. The IM window is on the right-hand side of the screen, and we'll do our best to answer every question as they come up or during the live Q&A. So without further ado, I'm going to turn it over to my friend, Stephen Berg.
Paul, thank you for the introduction. I wanted to talk a little bit today about the background of NDT for those of you on the call that are not familiar with it. Given the vast improvements in technology over the years, particularly with the Mentor Visual IQ, HD Video Probe, or the MVIQ, Berg Engineering and Sales Company believes it would be appropriate to provide further substance to our presentation today and give a brief background on NDT. As many of you already know, non-destructive testing is the process of inspecting and testing parts for integrity. Some of those inspections are looking for indications and discontinuities or differences in the characteristics of the parts without destroying the parts or the serviceability of them. In other words, when you inspect or test a completed part, it could still be used if it is deemed serviceable. In contrast to NDT, other tests are destructive in nature and therefore done on a limited amount of samples by the sampling method, rather than on the materials or components that are going to be used in assemblies. These destructive tests are often used to determine the physical characteristics of properties, such as their impact resistance, ductility, yield and ultimate tensile strength, fracture toughness, and fatigue strength. But discontinuities and internal defects and differences in material characteristics are more effectively found by using current NDT methods. Today, the modern NDT is used in manufacturing, in-service inspection to ensure the integrity and reliability of products and processes, and to control the manufacturing processes, lower production costs, and to maintain a uniform quality level. Current industries today using NDT are aerospace, power gen and power utilities, automotive, railroad, infrastructure, manufacturing, marine, medical device manufacturers, mining, metal forming, and oil and gas. Paul, I turn it back to you.
Hey, thanks, Stephen. So There are several methods used today, such as eddy current, or you'll hear people call it EC or electromagnetics, radiographic testing with X-ray and digital X-ray, ultrasonics or UT testing. There are methods called dye penetrant testing with PT or FPI, fluorescent penetrant inspections. And for the purposes of the presentation today, and what we want to share with you is more detail on remote visual inspection. Remote visual inspection, or RVI, is a cost-effective inspection technique that's used for the capturing of real-time videos and images from inside a void, such as pumps, pipes, tubes, valves, motors, rotating machinery, engines, recip engines, electrical motors, heat exchangers, tray towers. You can look inside of refractory line vessels and closed structures where confined space entry can be avoided. Remote visual inspection is required anytime that an object is to be examined and that object is more than 24 inches away from a direct line of sight. Video borescopes that can accomplish such an RVI task. RVI can also be a complementary technique to these other NDT disciplines, and it's frequently used as a primary or initial inspection to find localized corrosion, erosion, or other types of indications. So now that we've touched on these other NDT methods and applications, and RVI specifically, let's look at this new technology we want to share with you and what you can expect from the Mentor Visual IQ HD video probe. So also, as you may be wondering, yes, we will be providing a copy of this white paper afterwards, and you can certainly let Stephen Berg know that you would like to have a copy of it. So in the realm of new RVI technology, or portable RVI technology with embedded expertise and remote collaboration, this has enabled NDT professionals and asset owners to drastically reduce the risk of serious failures without experiencing the unnecessary equipment downtime that sometimes comes with that. By making RVI technology more efficient and reliable and accessible, the aerospace, oil and gas, and power generation industries have already greatly improved uptime for systems and equipment, ranging from, like I said, the tray towers and columns, or high-value rotating equipment such as gas turbines or aircraft engines. But while these video borescopes are of critical importance for visual inspections in these applications, the potential of what previous RVI tools could yield remains somewhat limited by resolution or the ability to resolve an indication in an inspection area. On the spot decision making is subsequently hampered by the standard definition provided and the limited working range that standard borescopes offer, especially when trying to determine the size of an indication. And as compliance regulations have tightened across industries, increasing pressure for more precise inspections continue to mount. And at the same time, the organization must also grapple with the challenges of reducing operating costs while simultaneously making process and test improvements. As you can imagine, the need for faster, more accurate inspections and the tools required to achieve them has never been greater. With that said, we would now like to go into some of the latest technology that the new MVIQ brings to the market and delivers in terms of the challenges we just mentioned. As many of you know, achieving the highest probability of detection, or POD, to determine an asset's health or locate indications such as pitting, cracking and corrosion, or other indication types is crucial. An increased level of image quality can help to significantly reduce risk, save on downtime, and therefore save on costs. The MVIQ achieves this through some exciting new technologies, and my colleague Tom is going to share some of this with you.
Thank you, Paul. This new technology we employ with our TrueSight imaging platform, and this allows our Mentor Visual IQ HD to deliver a 1.2 megapixel high-def image using a high-intensity light source, numerous layers of image transformation, and superior video processing, and allows enhanced RVI in both small parts and in larger voids as well. With high definition enabled digital zoom, you can hone in on even the tiniest indications mid-inspection before noticing pixelization that you'll see in lower resolution platforms. High def image quality and new optical tip adapters allow for better visualization and an accurate measurement from increased distances, increasing the potential measurement surface area size while also generating a more viable, fully surfaced XYZ point cloud. To obtain usable images would have otherwise required multiple tip changes, adding significantly more time, or in some cases, not even allowing the inspector to make a determination. The results are clearer, sharper videos and still images right on your device, which can also be live streamed to remote subject matter experts. And as you can see on the screen, the difference as we look at a dollar bill as an example, the increased resolution of the lower image stands out really well. I'm going to turn it over to my colleague Paul now, who will take you through a couple more examples of this.
Yeah, and while we're still on that same slide, Tom, thanks for sharing the differences in the resolution with zoom on the dollar bills. Something else that we've done in the MVIQ, if you look on the lower left slide, many of you are familiar with high dynamic ranging. You have a smartphone. Sometimes the picture is darker in some areas or brighter than others. And so we've installed the ability to do high dynamic ranging. And that's what you're seeing with the picture on the bottom left. And you may think, okay, so what? Well, the big so what is that on some indication types, when you're trying to measure upon them, the standard white light image just simply will not reveal the true ends or beginnings of, say, like a crack or surface erosion or corrosion. See those images much more clearly with maybe a HDR bright or an HDR image itself. And then in the middle picture there, we've also added these image transforms where you have the ability to adjust the screen, not only brightness, adjust the camera gain and the light output of the camera, but you know that in some areas where the image is far away, it's big and dark, camera noise will get massively snowy on the image, and the adaptive noise reduction will take that snow out of a over-gained processor or video circuit. Distortion correction, as far as I know, we're the only people that are doing that today, where with a wide angle field of view, the blades, if you're looking at a turbine, will be barrel distorted or curved, quote unquote. People think, oh, it's a bent blade, but distortion correction will show you the true picture of that blade and its true configuration, meaning you won't have barrel distortion around the edges. So we would go through all these types of transformations, image transformations in an introductory session when you invest in an MVIQ. But let's go back to what Tom was talking about on the high def and on the ability to resolve smaller targets on the next slide. And so you'll notice when you're looking at this, this is a starburst pattern with a standard def camera on the left. If you look at the white dot in the middle, start moving from the center out to the edges, I truly can't resolve the difference in the line pairs until I'm beyond the first, second, somewhere around the middle of the third starburst pattern can I start to resolve the target and know that there's separation in those line pairs. And then when you get all the way out to the edge of the starburst, you'll notice pixelation in the target. Whereas if you go over to the HD image on the right, I can absolutely resolve line pairs just outside of the second white ring. And you go all the way out to the edge of the image and you're not seeing any pixelation. So this is an untouched image without zoom on. And on this next image that we're going to look at, what you're going to notice there is your traditional U.S. Air Force 1951 target. This is just done with the standard built-in optics. And if you start looking at the elements, 02 on the top left, absolutely resolvable. 11 on the right, resolvable. When you start going down through these and start looking at them, I'm able to resolve line pair targets in the middle of that 1951 target. Then on a nozzle, this is a power turbine nozzle. You can see on both images, there is a somewhat horizontal crack starting at the stator on the right that has the glare on it, moving off to the left. On the HD image, you can see it going well below the white dot that is just above in the middle. But if you look on the SD image on the left, it starts becoming undiscernible well before you can see it on the HD version on the right. So not only do we have true sight imaging, the next thing I want to mention to you is the real 3D imaging that's available. And the reason we want to make sure that you understand the difference between real 3D stereo and standard stereo or 3D phase is because not only does 3D phase have on-demand measuring that's powered by algorithms that create this visualization of a 3D surface, but no other borescope has the ability to provide that, not even with traditional stereo. You'll hear people talk about traditional stereo as if it's 3D, and it is. It's a 3D coordinate measuring system, but the data that you see for measurement data is only presented as a numerical value that's relying on precise, and let me just say that again, if you ever do measuring, make sure you're getting precise cursor placement and exact matching of the cursors. And if you don't, you will not get accurate measurements. It doesn't matter whose borescope it is measuring with your traditional 3D coordinate stereo system. However, real 3D is going to allow you as an inspector to see where the cursors are placed on the 3D image while viewing it on the left side in the white light image. You get to see these side by side. And both of the images down on the bottom right, you can see a weld. Two pipe floors, in this case tubing, are joined together by a weld. And on the right-hand side of the image, the 3D point cloud has been rotated to show you what's actually going on with that weld. And on the bottom right, this is surface corrosion. And you can see that there, on the left side of the white light picture, is a deeper area that goes from the blue, green, turquoise down into the abyss of the darkness of that erosion pit. And the point cloud's been rotated to show you, yes, you have not actually chosen the deepest part of that erosion pitting. So Real 3D offers you wider fields of view and greater focal ranges during inspections and while measuring. 3D phase measurement on demand eliminates the needs for, when you're using stereo, you have to locate an indication twice. First, you go in, you do the inspection with a standard lens, find the indication, determine that you have to measure it, you pull the camera out and install a stereo lens. And then with a great bit of difficulty and certainly a lot of extra time, you have to go back in and relocate that same indication with a smaller field of view stereo lens to actually measure the indication. So on the next slide, I want to talk about one of the real key advancements with Real 3D scanning and this introduction of a new long-range 3D measurement optical tip adapter. This is a far-focusing tip adapter that provides you with more accurate measurements of larger features and more challenging surfaces at a greater distance. You can get almost twice, if not more, of the standoff distance from the target other types of technology. And it actually will let you measure two, and depending on the target, even greater surface areas. Advances in that 3D point cloud measurement is what's making the VideoProbe an increased tool for inspectors in the aerospace and power generation, manufacturing, the oil and gas industries. All of these have shown that they're able to get more accuracy, more precision when it really matters. Alongside accuracy, we know that it is often very challenging in a rugged environment in which inspections take place. And so we've really made a lot of strides in improving the productivity and versatility needed in these situations. Some of these additional improvements that I'm talking about are on-device workflows or data management and improved assisted defect recognition to give you easier access to more intelligent data and helping you increase productivity and make the best possible decisions in an asset faster. Focusing on design and data management and collaboration as well are some of the areas we've worked on. And we're going to run through some of these in the next slides in greater detail. Not all indication types can be seen in a white light image. So that's an area that we want you to be aware of, that the Mentor Visual IQ is often used in, examining surfaces using white light. Those are the traditional images seen on a typical scene where the lighting is from a white light source and it produces true color renderings of the surface being inspected. However, as you may know, there are inspection requirements, which employment of penetrant testing or fluorescent penetrant inspections. And these inspections are often used to examine the surface for very small discontinuities that are difficult to resolve with a white light image. Instead, a penetrant is applied to a surface for the prescribed dwell time and then cleaned from the surface, and a developer applied. And then the area is fluoresced with a UV light source, which meets the examination requirements as described in the ASTM section E1417. And the MVIQ with UV, I've seen it in a number of applications now, has been proven to meet these requirements in the field trials we perform. So to talk about more about this complete solution, Tom, I'm going to hand it off to you to talk about menu-directed inspection, please.
Thanks, Paul. I appreciate that. And so, yeah, what I want to talk about is a complementary set of software that runs on our Mentor Visual IQ platform and other platforms, video borescope platforms that we provide. What this does is it really takes the guesswork out and really more efficiently produces inspection reports and inspection data for the customers. So it's consistently going to name your images, and you have the power to set this up. Your inspectors can set this up ahead of time. And then each time you do that inspection, regardless of who does the inspection, you'll be consistently naming the images across those inspections. Data quality improves as a result of that, and there's a large time saving associated with that by making this decision-making process easier and being able to go through a step-by-step process. This also eliminates the need for manual note-taking and then trying to redirect those notes to certain images either at that time or later when the inspection is over. Automatically and consistently tagging this data across the fleets right at the time that you capture the information makes for search and retrieval of this information out of a database much easier. And we have a click-to-report capability. So right on the product, you can generate a report and then share that report directly from the VideoProbe in a customizable report that you could set up in a number of different ways in our settings menu. Alongside this, we have another set of software tools. And Paul, if you could take the audience through that, I'd appreciate it.
Yeah, you know, Tom, even with the images named the way that you described, where they're meaningfully named, and even with the reports that can get sent to anybody in the world, I've put borescopes in so many areas before that I really needed help understanding what I was looking at. You know, I'll tell you, I'm not a turbine subject matter, and if I was putting a video borescope in a turbine and didn't quite know how to make a good call or a bad call, I may want to give somebody else in the world the ability to see what I'm looking at so that I can be able to make a better informed decision. So what that's going to allow me to do is two things. One, as soon as I finish that report or take pictures, they can be shoved up to this inspection work suite and specifically to the Insight platform. And once they're on the platform, there are anybody on the network that has secure access to it have the ability to look at all of the images, all the pictures that I was able to capture, the report that I was able to make. They have it in internet speed, so it can be available to the masses on that secure network almost instantaneously. As far as we know, it's the only solution of its kind where you can go in and retrieve the data, share the data, remeasure upon it, search it in meaningful ways for various meta tag data. You can look at the videos that were recorded or the still pictures that were recorded, and your inspection and maintenance data, while it's available to a few, is to it has been provided to them. And then, Tom, do you want to talk a little bit about Connect?
Yeah, thanks, Paul. Connect is really a great tool. As Paul said, sometimes you may be tasked with making a decision on an asset, something maybe abnormal you hadn't encountered before, where you would want to get an expert involved. This typically would require stopping the inspection, getting somebody into the area. Many times would have to come and look personally. With Inspection Works Connect, you actually can, right from the device, make a connection to a remote expert who could be anywhere in the world. And from there, they'll real time be able to look at what you're looking at, and then together you could make the best decision possible on how to handle that particular indication. It's got screenshots. You can text message back and forth, add comments, including annotating on the screens and more. It really is a handy tool to troubleshoot some of these complex issues that may come up, and again, not leaving the inspection site. So way more efficient than stopping the inspection and having to have somebody come on site to do that work. Other tools available with this that go hand in hand with these products are the ability to do some remote expertise on the product, some remote troubleshooting or be able to use the product away from the video borescope itself. Paul, do you want to share some words on that capability?
Yeah, Tom, what we're talking about is iView Remote. iView Remote is an app that one can download onto an iPad. It's going to give you the ability to have command and control of your Mentor IQ, the Flame headset, the new one we've just released. And with that iPad attached and tethered, we're working on a wireless version today, it's tethered, I can have full command, control, and display. So you can have multiple people operating the system, monitoring the inspection, or in areas where I need a better ergonomic situation, you can just carry an iPad to the inspection point and leave the IQ setting on a stand just off to the side. So we've talked about a lot. I'm sure you're having questions about what does this really look like? How does it play? How does it feel? And what we're going to do is show you a live example of some of this technology, and it'll be streamed from the Mentor Visual IQ. So in this case, I'll go to Inspection Works Connect and initiate a session. And when I start this session, what you're going to see is that a set of credentials come up with the session ID and the session password. I can email that, say, to Stephen Berg, and Stephen will get an email that if he clicks on the link, he will have pre-populated credentials of the session ID of 071965 and also the pre-populated session password of 778380. And from there, if he were to get that email and click on it, he would get a live link. Me, as the inspector, what I would get on the other end is a session ID or a banner across the top that says that Stephen has joined the session. And when I start sharing video, it'll actually start sharing video. And he'll be able to watch this session live throughout the duration of the inspection. So from there, Stephen wants me to run a menu-directed inspection for a particular asset. And in this case, the asset is down there on the bottom center, the YT706. It's a turbine. And on that YT706, ahead of time, Stephen said the things that are important and critical are engine serial number. The things that are important and critical are engine serial number and inspector's name. You see, they both have asterisks. And so I have to put information in there. So on the engine serial number, and you see that I'm now sharing video. On the engine serial number, I'm going to take serial number 78-789 for the engine serial number. For the inspector's name, I'm going to choose mine. And for the position on the aircraft, this was sitting on the number 1 side, on the left side of the aircraft. The other engine serial number is 78, and we'll call it 456. You go through all of these fields. A reason for removal. We'll put over temp, and get that little typo out of there. And then the next thing being looked for is time since new. Time since new is 1,569 hours, and the time since overhaul was only 500 hours ago. And you continue filling these in. You go through all of this information that is being requested by Stephen as a subject matter expert. So let's call this November 4512. And then we'll also populate the operating environment. We'll just say it was in a dusty environment. The unit, this was for the air ops team. And lastly, the ops location, we'll call it Continental US. Say done. When I'm completed filling out the inspection summary, I will save this onto my internal D drive, noted up on the top left. And now I'm going to actually measure something in an asset, and the first thing that I will want to do is actually look at a target. This is an NIST traceable target, and down on the bottom you see I'm doing a measurement validation. That NIST traceable target I'm able to measure upon and determine if this scope is in calibration. Bottom right, select measurement, and you'll see that the verification block was detected and assisted verification is enabled. This is a way of speeding up the process so that when, say I select a length or a point to line, the two with the blue dots, either one of them will give me results that measure on both of those targets. The 0.1 inch target, you see I'm measuring at 0.100. The 1 millimeter target, you see I'm measuring it at 0.39 thousandths of an inch. And if I touch that, it will actually change over and give me the metric measurement. This system is considered in calibration with the performance level I'm getting now. So I can now go off and make asset measurements. But I want to save this image because I want to put it in my report for a menu-directed inspection. So now let me say save. I've now placed the scope inside of an asset, and I'm no longer on the top left doing a measurement validation. I touched it, and in fact, I'm now looking down on the bottom left in the PS blower, the particle separation blower, and I'm looking at a shroud surface. So I see an indication off to the top right. If I articulate towards it, I'll now be able to make a measurement upon that and say, let's determine how tall that object is. If I select 3D PM, I'm now capturing some 40 to 48 pictures. Bottom right, select measurement. Let's say I want to know how tall it is. I can actually select depth. Put two cursors on one side of it, straddle it to the other side. My green surface mask is telling me that I'm on a fairly flat surface surrounding that indication, and that I'm getting 1.37 millimeters, or if I touch that, so let me cycle through to make it active, get it out of the measurement area, touch it for about a second and a half, and you see that I'm now getting 54 thousandths of an inch. Really? Let me look at the right side on the point cloud and see if I'm actually measuring with the three cursors on the surface. Yes. You'll see some peaks on the top of that where my fuchsia line is coming off of the blue box. I'm measuring to the top of that indication, and when you get indications that look like that, I have a noisy image, meaning that if I were to measure on one of those peaks, I would certainly get a value much greater than that 54 thousandths. You see I'm moving towards them, and somewhere in here there's 50, somewhere in here there's 48, 49, 50, 48. So you move this around, I'm getting somewhere around 50 thousandths or more, and that's how you start assessing the target surface. Now, if I were to save a picture of that and save it with observations that say it was dented, and I could also let the inspector on the other end know it was noisy, so I didn't feel confident in it being a valid or maybe necessarily an accurate measurement, I can save it with a flag. So what's happening now, if you look in the file manager, this menu directed inspection has created a folder. You see up on the top left in the D drive, I've created a MDI folder, YT706 dash the engine serial number, and my pictures are already pre-named. And not only are they pre-named, look at the detail. See the picture up on the top? Measurement validation, number 1. If I look at this power separator blower, it's been flagged, and also on screen, it's labeled particle separator blower. So that's the value of the menu direct inspection. You get meaningful file names, and at the end of the results, you can actually go into the MDI and generate a report. And go back to a live image. See the YT706 on the bottom. I can go to my reference material where maybe I wanted to put the procedure in there for the remote inspector to look at. Okay, and at the end of the event, I can actually go into the report generation mode and generate a preview. And it looks like my cover page is not there, so I will change my cover page to just simply a default cover page. And I'll do the same thing. EndNotes none are selected. Do a preview of that. So here's your cover pages that are generated by MDI. There's the inspection details. You see that I was filling that data out at the beginning. On the lower left, you see that in the compressor, combustor, and turbine, there are no images taken. They're yellow. And in the measurement section, there was, middle column, one picture taken. It was not flagged. But on the particle separator blower, red, there was one flagged image taken. So you have this ability to go in and collect meaningful data that has tagged by section, stage, depth, or whatever you define, particle separator, blower, shroud. You know exactly where you were. The file name is meaningful. There is meaningful text on the image, and you see that I have my measurement value also in the report. One last thing that I'll show you is the visual of what a clean point cloud looks like. And so in this case, I'm looking where two tubes have been joined together and welded. There's a weld strike point off on the far right. And what I may do just to start at the beginning is delete that measurement, and I'll add another one, and I'll add an area depth profile. I'll hide those keys so that we have a full screen view. Put one cursor on one side of the weld and one cursor across the weld, both on the same side or the tube floor. And the white line between those is following that tube floor in 3D space, calculating that curvature. When I touch below the weld on the other side, you'll see that there's a white line horizontally across the bottom. It is actually mimicking the line across the top, and it's picked the highest point of 41 thousandths of an inch on that strike point. Let me look at the point cloud, and first I want to see if it's clean. Remember, the last one had noise in it. It was very bumpy, if you will. This one is completely clean, and I would tell you that I feel confident that that point there is some 41 plus or minus a thousandths of an inch above the pipe floors that those planes were established on. So from there, we're going to go back to Tom, if you will, and talk about the system's portability and design and what we've done with the operational characteristics.
Yeah, Paul, thanks. The Mentor Visual IQ was created after numerous trips, visits, watching inspectors work, asking them what were the things that are most important to them. And so we tried to put a lot of that and most of that as we could into the product. So portability, a key area for folks that are doing inspections all over the world. This is a very aircraft compliant solution. You can take it in the overhead compartment so you can fly with it. Lithium ion battery and both battery or AC capable powering for this product in a very small, less than 7-pound package. One of the other areas that's really important to our customers is durability. They need the product to work when they're using it. So we've designed this to meet an IP65 requirement. This allows the system to be used in both dry and wet environments. It meets military standards, both the military standard 810G and the military standard 61F. It's able to be used in high temperature environments. It can be used up to 100 degrees C, and it'll stand up to those severe environments. We test it in that way. And again, to be both water resistant and even dust proof when you get into certain parts of the world where there's sand and dirt flying around in the air. You never know where you're going to be. And then from a user ability, we've integrated an intuitive touchscreen into this product. We were the first ones to market with a touchscreen, and we've allowed our customers to use it in the more traditional way with the joystick and the buttons. But depending on what they're doing, what type of inspection they're doing, whether they're measuring, whether they're annotating, whether they're navigating around in an asset, the touchscreen can be much faster and easier for those areas of inspection. And with our gesture-based pinch to zoom, and you'll notice with HD, this pinch to zoom is going to allow inspectors to really get a look at something without having to push the probe in further or retract it and take out and put on another tip optic. So really efficient from that standpoint. One thing to note, it'll work with your gloves. So any inspectors that need to wear gloves, they found that works quite well there. And we've made a real improvement in our LCD display, very clear and bright, and you can see it really well from multiple angles. So just a really intuitive product. Paul, I'm going to hand it over to you now, and maybe you could talk a little bit about some of the applications and verticals that we support with this product.
Yeah, I appreciate that. There are a number of industries where there is great benefit from visual inspection. And turbines, the whole idea is there a safety of flight issue that needs to be addressed, or can we put our loved ones on board this machine? And so having an enhanced probability of detection at all stages of the engine is going to be paramount to performing a good and thorough inspection. And when you're out on the flight line and you're trying to determine if this aircraft is grounded and I've got an AOG situation, it's going to improve your turnaround time and give you faster, more accurate go, no-go readings. And when you do see indications, when you're using real 3D surface analysis with a fully surface point cloud, and you're able to go in with true site imaging and get true pictures of what's going on inside of an asset, it's going to be a much better, faster, more accurate and precise measurement. And again, some of the onboard intelligence that we talked about earlier with the menu directed inspection, it's able to store reference of good pictures, bad pictures. Some people are storing aircraft maintenance manual reference pages or engine maintenance manual pages, so that when you're in the middle of an inspection, you can actually look at that data and determine if what you're looking at is good or needs further analysis. And at the end of the inspection, as Tom was saying earlier, you can generate a report on demand and send it upline or shove it up to the inspection works insight server. So just like in the aerospace industry, technicians in the power generation sector are looking for some of the same things, but also have their own very unique set of needs. In power generation, they're really looking for things that can be smaller, more compact, rugged, can be operated hands-free, or they can walk around the turbine containment area with a handheld unit to make it easier to go from inspection point to inspection point. And they need the inspection process to be faster. They want it to be easier. And so what we've done with onboard intelligence is allow these inspectors to set the machine up with profiles and with preferences for how the machine operates and how the display is performing as far as lighting or distortion correction or noise in the screen elimination. And so that's all set up easily depending on the inspection conditions that they're working under. And as you can imagine, working on a penthouse of a boiler system that's 5 stories off the ground, things need to be rugged. They need to be able to withstand dusty, dirty environments. So that kind of capability and functionality is built into the system. And once they're inspecting and are looking for flow accelerated corrosion or pitting or cracking or wear, or on rotating machinery, they may be looking for turbine tip rubs, they'll need the bright HD imaging capability that the Mentor Visual actually provides. And then with the probability of detection package, you turn on things like distortion correction or high dynamic image ranging to allow for better analysis and measuring. So with that, I want to say for Tom and myself, thank you very much. We thank you for joining us, and we'd like to hand it over now to Stephen and his team at Berg Engineering for a question and answer session. Thank you very much.
Paul and Tom, thank you for helping out with the webinar. Looks like a lot of the questions were already answered. Anyone at this time can unmute their lines if they have any questions, or they could type it in. One item I wanted to go through was, again, these the Mentor IQ is an adaptable instrument. You can add additional probe lengths and diameters and measurement tips or regular tips for future applications as they come necessary. And if anyone is interested in seeing a demonstration on site, we're happy to assist. We could come in, one of our sales team, and work with you on your applications and your requirements. So we'll sit tight and see if we have any questions that we haven't answered, or anyone can chime in.
Stephen, I'll say that there were a couple of times my audio was clipped. I was was having some voice over internet delay, so I regret that. I don't know if the messaging came through completely clear to everyone on the call during some of it, but if there were areas that you wanted to explore, I'd be happy to cover or recover any of the material or anything else you're thinking about around 3D imaging and 3D measurement, those kind of things.
Yeah.
Any thoughts or questions on any of that?
We do have one question about the OD of the tips.
Yep.
Yeah.
So on the OD on those tips, the HD version would be a 6.1 millimeter, and then we also make basically the standard def in 4 and 8.1.
Yeah, Stephen, thanks. And then also on the 4.0 millimeter on that small camera, we also have the fully surface 3D imaging, and it is in a stereo format. So that 3D stereo, which has a real 3D component to it, is available on the 4 millimeter, the 6.1, and the 8.4 millimeter. And there's another question about how long can we inspect, and that could mean a time frame or distance. So with 3D measuring, we have cameras that are long steers that can be deployed up to 100 feet or 30 meters away. So that would be in a 6 millimeter or 6 millimeter format with that 3D measuring on it. But we also have other cameras types that can be deployed quite great distance further. So we'd really love to sit down and talk about what's really needed on the inspection point so that we don't give you any kind of false hopes that we can get it done. But typically 100 meters with, 30 meters with this Mentor Visual platform is the limitation on it. Then, Stephen, I'm seeing another question about file naming. Is it set up for a file format, and can the files be files be hard to search? Yes, files can absolutely be hard to search, because if you set this video scope or any video scope up without some file naming structure, you're going to get a generic machine name. Today's going to be 2019-01-23, number 1, number 2, number 575. So what actually happens is with menu directed inspection, I sit down on my laptop, I go through all of the required inspection points, and I define a folder structure that will then meta tag pictures. So if I'm going into, say, some kind of a boiler section, or say I'm looking at piping, I can say entry end, exit in, mid-span, radial weld. I can define all of the inspection points in that asset, and then the picture comes out: weld bezel, near side floor, weld reinforcement angle. You just define it on the front end. Then you take that file and give it to one person with a Mentor Visual IQ, or 50 people with 50 different Mentor Visual IQs, and they're all inspecting and naming things exactly the same. So not sure if that is exactly what was being asked on that, but if not, come back with a follow-on question in the questions window. And then, Stephen, there's also a question about what is the smallest ID we can inspect. And with a straight video scope, we have video scopes as small as 3.9 millimeter OD. However, because the Mentor Visual IQ has quick change probes, I can pull off a standard probe. I can put on a borescope adapter, and I think we're all familiar, or maybe not, but there are optical instruments you can put up to your eye and look down through them, whether they be rigids or flexible scopes. And we have flexible scopes as small as 1/2 of a millimeter. You can clip the borescope adapter onto this 1/2 millimeter flexible scope and now have 100% of the functionality on your Mentor Visual IQ, except for the precise measuring capabilities. You can still do comparison, but you won't have stereo. You won't have 3D stereo or 3D phase, but you will have the ability to document with text annotation and the like, and shove it up to the Insight server. So there's another question about what's the approximate price of a Mentor 6mm with 2 meters, and you know the Mentor video scope starts somewhere in the low 30 US, and it can go north of that depending on 1 probe, 2 probes, 5 probes, 1 optical tip adapter, 10 optical tip adapters, and all the other accessories. So I think of it starting in the mid 30-ish kind of range and going north depending on the problems that you're trying to solve and how far away they are from the inspector's entry point. So that's a good question. So I don't see any other questions in the question box right now, but just curious to know if anybody else has live. We can talk about them live, or still post in the chat or question box in the poll window to the right. You know, one of the things I started with is the service and capability that Stephen and his team there at the Berg Engineering Company provide. On the front end, we really have to sit down, and Stephen or his folks will come do that and just understand, what are you trying to look at? Where is it? What's the travel path? What's the environment? And, you know, golly, it may not be a Mentor Visual IQ. There may be some other tool in the toolbox that Stephen has. So, and by the way, it may not be remote visual. I would love it if it is, but if it's radiography, ultrasonics, eddy current, we at GE Inspection provide those solutions also. But it's really about understanding your needs and having Berg's team sit down and help you understand what the investment could look like. And then once you've made that investment, Stephen or his team will come out, give you a couple of hours, absolutely no charge on-site product training and orientation. And then myself and a couple of my colleagues conduct training around the world, where for a fee we'll conduct 1 to 3 day trainings either at your site or at our factory. And we currently have one coming up next week, next month at our factory in Skaneateles, the week of the 18th of February. And I think we'll have 8 or 9 more coming up through the rest of the year.
I have a email here from the webinar. Someone asking about typical delivery. It depends on configuration. Typical delivery, it's fair to say about 6 to 8 weeks, if not sooner, depending on the configuration of the package.
Mm-hmm. I would mention to you also that this is equipment that we have a rental office there in Chicago, and there may be times when you're too busy or not qualified to do some of the things that are needed done. So we also have a services office, so you can talk to Stephen about the full solution there whenever you're trying to decide what tools to put in your toolbox. Any other commentary or questions or things that are on your mind around particular application issues or around this particular piece of kit or other things we may be able to help you with before we wrap up here? I know somebody's wiggling in their chair thinking, I really want to ask that, and I bet you do, because somebody else probably has the same question. Any other questions that you're sitting on that you may not feel quite comfortable stepping over the threshold, but go ahead and do it? So Stephen, I'll turn it back to you.
All right. Well, I want to thank everyone for attending our webinar today. If anyone is interested in a white paper, just let us know on what we presented. Again, if anyone's interested in seeing more information or a visit from one of our technical salespeople on site, again, let us know. We're happy to assist. I wanted also, again, thank Paul and Tom for assisting with this webinar. And we look forward to working with everybody. Thank you. And everyone have a very nice day.
Thank you, Stephen.
Thanks, Paul. Thanks, Tom.
Thanks, guys.